Okay, this is my pre-calculus. What's my sine and cosine lab number 2? And this is a cool one because we have a table below that gives the average monthly temperature of Y in degrees Fahrenheit. So let's kind of label that degrees Fahrenheit for the city of Fairbanks, Alaska, as a function of T, the month, where T equals 0 indicates January. So this is a big deal. This is, I think, some of the trickier ones. You got to remember that unless you want to write every trigonometric function that we do that has anything to do with time with a shift, if I let January be 0, which is what I have here, you got to remember that December is then going to be 11. So what I kind of do with this is write the months on here. So then if they ask me something, I know what month they're talking about, because I think when I think of April or May, I think of April is the 4th month and May's the 5th. And it's not in this case because January is 0. The other thing I want you to know is if I'm doing January to December, my period is going to be 12 no matter what, even though I'm going from 0 to 11. So the first thing we're going to do is plot all our points. So I kind of set this up. I looked at my high and my low temperatures, and my lowest temperature is negative 11.5, and my highest comes all the way up to 61.3 to figure out how I'm going to do my graph. So if we look below, I actually counted the squares. So the first thing I did was January is 0, so that's right on the y-axis and the x-axis right there. And then I counted by 1 all the way to November, and then December is here, number 11. Okay, so I still have 12 months of a year. And then I counted by 5s all the way up to 70 because I told you the highest temperature came out to be about 61.3, so that way that'll all fit. Okay, so now if you're looking at your points, I can't see them as I'm graphing this, but I do 0, January is a negative 11.5. So that's going to be down here if I count by, this is negative 5 and negative 10. Oh, excuse me, negative 10, I counted by 5s. So this would be negative 10. And this right here would be negative 20. So if I graph negative 11.5, it's about right here on the January that I wrote. And then the number 1 is negative 9.5, so that's about right here. 2 is 0.5, so that's about right here. 3 is 18, so 18 would be about here. 4 is 36.9, so that's about right here. 5 is 53.1, so 5 would be 53.1, be about right here. And remember, this is an approximation. 6 is 61.3, so that's about right here. And then 7 is 59.9, so that's about right here. 8 is 48.8, so that's about here. 9 is 31.7, it's about here. And 10 is 12.2, that's about right here. And 11 is negative 3.3, so that's going to be right in here. So it's kind of on the 11 here. So then I'm going to swing an arc through all these points. The best arc I can be, it doesn't have to be perfect, but that's what it looks like. So it's, my paper actually looks a little better. You just kind of swing it around and it's an approximation. Okay. So let's kind of go through, it says plot the points and draw a curve that best fits. It doesn't have to go through every point, but we did that. So that's our graph. The B is find a formula. So we always do looks like, and it looks like a negative cosine curve. So I'm going to put that there. And then we're going to do amplitude, frequency, period, and midline. So the midline is what I always do first. I'm going to take my high plus my low, which is a negative 11.5, and divide it by 2. And so my midline comes out to be y equals 24.9. My amplitude is high, the 61.3, minus my midline, or my midline minus my low, and I'm going to get 36.4. My period is 12 months, even though it's 0 through 11 equals 2 pi over my frequency. Solve for my frequency, so that's 2 pi over 12 or pi over 6. So already I know my equation here is they're using f of t, but I'll say f of t, so the temperature is going to equal. Now I'm going to put the midline up front, even though people don't really like that, but I'm trying to get you used to, sometimes you'll see that, minus 36.4 cosine pi over 6t. So this is just to get you used to this. If you wrote it as negative 36.4 cosine pi over 6t plus 24.9, that's perfectly fine. So there is an approximation of my data of all the temperatures in Fairbanks, Alaska. Now let's do the C part. The C part says, use your formula to solve f of t equals 32. So we're going to put it equal to 32. 24.9 minus 36.4 cosine of pi over 6t. Subtract the 24.9, and when I do, I get 7.1 equals negative 36.4 cosine pi over 6t. Divide by negative 36.4. Now, this is where you have to be careful. Write down everything on your calculator because you do not want to round it too quickly. So when I divided by negative 36.4, 7.1 by that, I got negative 0.195055 equals the cosine of pi over 6t. And then I look at it, no more normal math, so I'm going to do inverse cosine on both sides. Thanks for playing. So t equals 6 over pi, because we're going to multiply by the reciprocal, okay, times negative 0.195055. And when I do that, I get t to be roughly 3.37. So sometime, because April is 3, sometime in April is when the temperature is going to be around 32 degrees, according to our approximation. Now, the last one is a pretty cool question, and I'm kind of running out of room here, but it says, in the southern hemisphere, the times at which summer and winter occur are reversed. Relative to the northern hemisphere, modify your formula from part B so that it would represent the average monthly temperatures for a southern hemisphere city whose summer and winter temperatures are similar to Fairbanks, but they're flipped. So all you have to do is take your equation here, and you're basically, instead of making it a negative cosine curve, everything here would be like flipped. It would be opposite. So this is what I would do for D. So for D, I would just say, well, f of t for the new one, or we can call it g of t, our new formula. So let's do something different. So we'll do the southern hemisphere. They didn't really tell us to call anything, but I don't want to call it the same thing. So I'm going to say g of t for the southern hemisphere is going to be, instead of a negative 36.4, it'd be a positive 36.4 cosine pi over 6t plus 24.9. So it's the same formula, but it's not inverted anymore. And that would be a southern hemisphere. So I hope this helps you.